Welcome to this video, Integer Powers of Rational Numbers. In the previous video, we talked about the powers of 10 and the calculations on them. And I will put a link to this video in the description box. In this video, we will define the integer powers of rational numbers, a collection of rules to follow where these powers exist, and the order of mathematical operations within the algebraic phrases where these powers are involved. If you like my videos, please subscribe to the channel and share the videos with those who might be interested in this content. Now let's start. So let's at first define what integer powers of rational numbers are. So let n be a natural number where n is larger than or equal to 2, and let a be a rational number. If you are new to rational numbers, I will also put a link in the description box to the video that defines them. You can find also other videos that talk about natural numbers, integers, and real numbers. So we repeat again, let n be a natural number where n is larger than or equal to 2, and let a be a rational number. Then we define a to the power of n as a multiplied by a multiplied by a n number of times. So for example, if we have 3 to the power of 2, so here we have n equals 2 and a equals 3. So a to the power of n equals 3 to the power of 2, and this is equal to 3 multiplied by 3 twice, since n is equal to 2. So we get 9. So 3 to the power of 2 equals 9. We take another example. A to the power of n equals 2 over 3 to the power of 3. This is equal to 2 over 3 multiplied by itself 3 times, since n equals 3. So the result in this case will be 8 over 27. We have special cases when n equals 1. This gives us a to the power of 1 equals a. Sorry, here there is a mistake. It's a. And when n equals 0, this gives a to the power of 0 equals 1, where a doesn't equal 0. Let's take another example related to the previous definition, minus 3 to the power of 4. In this case, we have a equals minus 3 and n equals 4. So minus 3 to the power of 4 equals n to the power of a to the power of n, and this is equal to minus 3 multiplied by itself 4 times. So it is minus 3 multiplied by minus 3, and we repeat it 4 number of times. And this will give us, as we learned before, we multiply minus 3 by minus 3. This will give us 9. And minus 3 by minus 3, this will give us also 9. And the answer is 81. Now, if we have a to the power of minus n instead of a to the power of n. So what do we do when we have this negative sign? Here in this case, a to the power of minus n will be equal to the reciprocal of a to the power of n, which is 1 over a to the power of n. Okay, so for example, if we have 2 to the power of minus 3, in this case, a equals 2 and minus n equals minus 3, or in other words, n equals 3. In this case, 2 to the power of minus 3, and based on this definition here, must be equal to 1 over 2 to the power of 3. And this will give me 1 over 2 to the power of 3 is 8. So it's 1 over 8. This is almost the same idea. 3 to the power of minus 2 will be equal to 1 over 3 to the power of 2. So we move 3 down and we change the sign of the power, and this will give me 1 over 9. In a specific case, when n equals 1, specifically when n equals 1, this gives me a to the power of minus 1 equals 1 over a. That is 1 over a is the reciprocal of a. So let's now see a couple of rules for calculating those integer powers of rational numbers. We start with the first rule. So assuming a is a rational number and n and m are integers, then if we have a to the power of n multiplied by a to the power of m, then we can find the result by taking a and raising it to the power of n plus m. So for example, here we have a to the power of 3 multiplied by a to the power of 5. So in order to find the result, we take a in this case and we raise it to the power of 3 plus 5. Here 3 is equal to n and 5 is equal to m. So we will get a to the power 3 plus 5 equals a to the power of 8. So this is the first rule. Now we move on to the second rule. So here we have a product of a and b, which is a multiplied by b. This product is raised to the power of n. In order to calculate the result, we take a and we raise it to the power of n, and we multiply this result by b to the power of n, also assuming that a and b are rational numbers and n is an integer. So let's take an example, 2 multiplied by y, while y is assumed to be a rational number also. So the product of 2 and y is raised to the power of 3. Applying the previous rule here, the result will be a to the power of n, which is 2 to the power of 3, multiplied by b to the power of n. In this case, b is equal to y, so it's y to the power of 3. And this will give us 2 to the power of 3 is 8, multiplied by y to the power of 3. So this is the second rule. Now the third rule, also assuming a and b are rationals and n is an in n and m are integers. So in this case, we have a fraction or a ratio, if you want to call it now, a to the power of n over a to the power of m. So this would be equal to a and then n minus m. So in order to apply this in practice, we take an example, a to the power of 2 over a to the power of 3. So here n is equal to 2 and m is equal to 3. So the result will be, according to this rule, we take a and we raise it to the power of n minus m, which is 2 minus 3 in our case. And this will give us a to the power of minus 1. We have seen previously that this is the reciprocal of a, which is equal to 1 over a. So this would be the result. Now we move on to the last rule, which is a over b raised to the power of n. In this case, we raise a to the power of n and we raise b to the power of n to get a to the power of n over b to the power of n. So if we want to take a practical example, such as 3 over 2 raised to the power of 3, so in this case, a is equal to 3, b is equal to 2, and n is equal to 3. So this will give us a to the power of n, which is 3 to the power of 3 over b to the power of n, which is 2 to the power of 3. And this is equal to 3 to the power of 3 is 3 multiplied by 3 multiplied by 3, which is 27. And 2 to the power of 3 is 2 multiplied by 2 multiplied by 2, which is 8. So let's move now to talk about the order of mathematical operations when the integer powers of rational numbers exist. So sometimes we find brackets in the phrase, in the algebraic phrase. In this case, we perform the operations within the brackets first. But sometimes there are no brackets involved, so we have to follow the priority of operations. So we calculate the powers first, followed by the division and multiplication, and finally the addition and subtraction. So let's take for an example this algebraic phrase we see here, 5x to the power of 3 plus 6x to the power of 2 plus 3, when x equals 2 over 3. So this is equal to, the first step is to substitute x equals 2 over 3 in the phrase, in the place of x. So here, 5 multiplied by x equals 2 over 3 to the power of 3 plus 6 multiplied by x squared. So x here is equal to 2 over 3 here squared. And finally, we have plus 3. This is equal to, first of all, we need to calculate the powers. So we have 2 over 3 to the power of 3. This will be equal, according to the rule we have seen before, that says a over b raised to the power of n. This is equal to a over n, a to the power of n over b to the power of n. In this case, we will have 5, we leave it outside for the moment. And then 2 to the power of 3 over 3 to the power of 3. We close the bracket and we move to the second term, which is 6 multiplied by. Now exactly the same. We have 2 to the power of 2 over 3 to the power of 2 plus 3 remaining. And this is equal to, we still leave 5 outside and we perform the operation within the brackets, which is 2 to the power of 3 is equal to 8. 3 to the power of 3 is equal to 27. We close the bracket and we move to the second term, which is 6 multiplied by 2 to the power of 2 equals 2 multiplied by 2, which is 4, over 3 to the power of 2 is 3 multiplied by 3, which is 9, plus 3. And then now we have a multiplication and we have addition. So according to the set of rules, we apply the multiplication first. So 5 multiplied by 8 over 27, we multiply 5 by 8 to get 40 over 27 plus 6 multiplied by 4 over 9, we multiply by 6, we multiply 6 by 4 and we leave the denominator as it is, so it's 24 over 9 plus 3. Now we unify the denominators and we calculate the result. Let's move to another example. -3 over -4 and all raised to the power of -3. So if we remember, we have the rule that says a to the power of -n equals 1 over a to the power of n. In this case, we have a equals -3 over -4 and n equals 3, or in other words, -n equals -3. In this case, it will be equal to 1 over a, which is -3 over -4 raised to the power of n, which is 3. Now we can, first of all, minus and minus, this will give me plus sign. So we can rewrite it as to the power of 3. Okay, so this will give me again 1 over, according to this rule, 3 to the power of 3 over 4 to the power of 3. And this is equal to 3 to the power of 3 is 27 over 4 to the power of 3, 64. So this is the reciprocal of 64 over 27. So the result will be 64 over 27. Thank you for watching.